In this video we're going to talk about chain rule. Chain rule is for the derivative of compositions, when you take a function and put it into another function. For example, you take the parabola 4x squared and put it into cosine. So it's the cosine of 4x squared. So, compositions where we take the function g and plug it into f. Now in the end, when we find the derivative, we want how f changes, the big outside last function, with respect to our variable x, right? We want to know what's the derivative of f, because f is ultimately the last function acting on the variable, and that's what we want to know. How is that changing with respect to the variable? Well, the way we're going to do this, the first thing we got to think about, and this is actually a very simple proof of how we do chain rule. The derivative of g of x, well, the derivative of g of x is just dg dx. Right? That's how we write that with Leibniz notation, change in g with respect to x. So essentially, if you just ignored the f part and you just said, well, what's the derivative of this, g of x, it's dg dx. Well, I want to end up with an answer of df dx. I have dg dx. So the question becomes, if I just take the derivative of the inside, how would I get df dx? Well, this really goes back to some of the unit transformations or change, in science class. When you want to go from miles per hour to feet per second, you create a multiplication chain that helps you to do that. Well, that's what we're going to do here as well. I want to create some kind of multiplier to multiply dg dx by to get df dx. Well, I need there to be a dg on the bottom because I need the g's to cancel, and I need there to be a df on the top, so once the g's cancel, let me just circle them, I'm left with df over dx. Well, this is it. This is how chain rule works, and this is what it means. It means you're going to find the derivative of the big outside function with respect to the inside function. Essentially, the inside function is your variable, and then you're going to multiply by the derivative of the inside function with respect to x. So every chain rule will be a product. The derivative of the big outside function multiplied by the derivative of the inside function. Let's do an example. I mentioned the cosine of 4x squared. Let's do that one. I sometimes like to kind of box in my inside function to begin with. It just helps you get the hang of, how we're going to do, or what we're going to do with this. 4x squared is going to essentially be our variable. We're going to do df dg, where the inside function is 4x squared. So we're going to start by just doing the derivative of the outside, which derivative of cosine is negative sine, and we're going to leave the inside alone. Okay? And again, we're treating that inside function as our variable. So, the derivative of cosine of x is negative sine of x. Well, 4x squared is our variable, so we're just going to leave it alone and change the outside. But then we're going to multiply by the derivative of the inside, dg dx, which derivative of 4x squared is 8x. Now we usually like to have our trig stuff come last, so I'm going to rewrite this as negative 8x sine of 4x squared. And that's our derivative. That's it. Okay. Next, we've got 200 multiplied by 2t plus 3 squared. Okay. A lot of times the inside function, of course, has something with parentheses. Now again, that 2t plus 3, we're going to treat that as our variable. So when I have a variable squared, as I do here, what I do to get the derivative is bring that out front, multiply it by the coefficient. So f prime is going to be equal to 400. Okay, I'm going to leave the variable alone. It's now to the first power, so I drop the power by 1, and then I multiply that by 2. Now I could clean this up a little bit. 400 multiplied by 2 is 800 multiplied by 2t plus 3. And you could, of course, even go further, 1600t plus 2400. Now, I think a lot of people at this point look and say, you know what, chain rule seems like a lot of work. I know how to do this. I could have easily just written this as 200 multiplied by 2t plus 3 multiplied by 2t plus 3, multiplied it all out and used power rule. And that's very true. But imagine for a moment that it wasn't to the second power. Imagine it was to the 9th power. Would you really want to multiply that out 9 times? When essentially we could use chain rule, make that the inside function. So this is our variable. We multiply 200 by 9. We get 1800. 2t plus 3 stays the same. It's now to the 8th power. And we multiply that by 2. And we didn't have to expand it. We didn't have to actually do to the 9th power. So chain rule is extremely valuable, and it really is fast. You know, compositions were very hard derivatives to do by definition, that f of x plus h minus f of x all over h, and they're very easy now. Next examples. The tangent of 6x cubed squared. Well, as I said, a lot of times you get this help by parentheses. You say, well, okay, squaring is the outside function, so you know how I would normally deal with that, of course, is bring the 2 out front. The variable stays the same. Now it's to the first. And now I multiply by the derivative of the inside. Well, the problem is, maybe it's not a problem, but the interesting thing is, of course, we've got another inside function. 6x cubed has been put into tangent. So we have to use chain rule again. So the derivative of the inside, well, it's going to be derivative of tangent is secant squared. We're going to leave that 6x cubed exactly the same, and then multiply by the derivative of that, which is 18x squared. So we end up having to do chain rule twice because we had 3 functions at work. We had a squaring component, we had a tangent component, and we had the cubic function on the very inside. Now we could clean this maybe a little bit. 2 multiplied by 18x squared is 36x squared. Tangent of 6x cubed multiplied by secant squared of 6x cubed, and this is our derivative. Last example, the cosine of 4x times sine x. Well, I think, again, parentheses help us quite a bit. We say, well, okay, this is the inside. So the derivative of the outside is negative sine. You leave the inside alone because it is your variable. And we're going to multiply by the derivative of the inside. We have 4x multiplied by sine x, so the inside requires us to use product rule. So first, multiply by derivative of the second, plus second, multiplied by derivative of the first. This is our derivative. One last piece of advice I'll give you: if you're faced with something like this, where it's like f of x equals sine cubed of x. When I see something like that, I would rewrite it as the sine of x cubed, because then when you find the derivative, you know, you say, okay, so sine is the inside function. I bring the 3 out front, leave the inside alone. Now it's squared, and I multiply by the derivative of the inside, and it's very easy. But I would always rewrite it because it looks a lot easier. I mean, it's a lot more obvious that you're going to need chain rule if you rewrite it.